Hello grade 10 students. Today I am here to teach you chapter 19 in your textbook that's called Logarithms I. So here before starting logarithms we'll see what are indices. You have discussed this in grade 9. We'll take 3 times 3 times 3 times 3 times 3. How many 3's are there? 1, 2, 3, 4, 5, 6. So we can write this is 3 to the power 6 because there are 6 3's and this is like 1 here. 1, 2, 3, 4, 5, 6. Now when you write in index notation, what you call this one? That's the base value. And what about this one? Index. And the whole thing we can take as index form. So here you need to know what's the base, what's the index, and what is index notation or index form. Now we'll see how we can write this in index form. Okay, look at this one. The bases are 9. How many 9's are there? 1, 2, 3, 4, 5, 6. So 9 to the power 6. Now try to write down this one. How many 10's are there? 10 is the base. 2, 3, 4. 10 to the power 4. Now what's the base here? Minus 7 is the base. How many times you get minus 7? 1, 2, 3. So you put 3 there. Now here A is there. It says 10 terms. 10 times you are multiplying. So what's the power? A to the power 10. If there are n terms here, x terms n times. What's the value? Index form. X is there, that's the base. You are multiplying x n times. Power should be n. Now, try this one. Here we can write 2 times 2 times 2. 2 separately and a separately. Or 2a, 2a, 2a. So we can take, this is one term. How many times you are multiplying 2a? 3 times. So here when you are taking the whole thing, make sure that you put brackets. 2a whole thing power 3. What about this one? Don't get confused with this one. This is just only 1, 2. You can't put brackets. Just 1, 2 is there. A is just multiplying 3 times a to the power 3. Here we don't put brackets. What about this one? xy, xy, xy. So we can take this one as one full term. We can write xy to the power 3. 3 times you are multiplying. This one, x is just once. Y you multiplied 3 times. Y to the power 3 times. 3 here. Look at the difference between these two. This is x and y both are multiplying. Here only y multiply 3 times. Now we'll do the other way around. Expand and write down following index notations, index form or index notations. 8 to the power 4. How can we write down? 8 4 times. 1, 2, 3, 4. Here what's the base? Minus 11. We can write down minus 11 3 times. Put brackets when you get a negative value. This one? There's no brackets. That means 2 is not multiplying 4 times. Only x multiplied by 4 times. So here just 2 is there. X multiply 4 times. This one, the whole thing bracket 4 times. That means 2x, 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 2x. This one no brackets, so just a multiply once and b 4 times. This one, there are brackets, so whole thing multiply 4 times. So this is other way around. If the index form is given, how we can expand that. Now we'll take this one. We know 9 times 9 times 9, 5 times. You can write 9 to the power 5. So I want to just separate this. I want to take these 3 as one bracket and these 2 one bracket and write down. Now, what is this one? 9, how many times? 1, 2, 3, 3 times. This one, 9, 2 times. And this becomes 9 to the power 5. What can you say? Base is the same. Here 3 and 2. How you get 5? Just think about it. 3 and 2, you can get 5. 3 plus 2. So try to understand the pattern you observe. So here we can see 3 plus 2 is equal to 5. When you multiply, powers you can add. We'll see this pattern in some of the examples. Now we'll see by using the previous pattern what we can write. The 2 terms are multiplied. What we observed? You can add the powers. So 3 plus 4, you get 7. Here same base, multiplication, you can add the powers. 2 plus 3, you can write 5. Same base, addition, x and 3, you can write x plus 3. X is the same base, powers are a and 2a. A plus 2a. What is a plus 2a? You can write 3a. This one, same base, x and 2. Add the powers, x plus 2. Here, a, m and x. M plus x. All these multiplications. Same base, multiplication of different powers. A and b, that means a plus b. Here, y is the base, p and q are the powers. We can add the powers. So, what we can write? So, you have to remember now, when you get same base, different powers, multiplication, what you get? We add the powers. So this is the first law in indices. Law number 1. What is law number 1? When you get same base, multiplication of different powers, we add the powers. You get the same base, but we are adding the powers. We can write down when you multiply same base. So this is important. Same base, different powers. Multiplication add the powers. Now we'll take this one. We want division now. 9 to the power 5 divided by 9 squared. We'll expand 9 to the power 5. How many times? 1, 2, 3, 4, 5. Divide by 9 squared. How many 9s are there? 9 times 9. Now simplify. This 9 get cancelled out with this 9. This 9 get cancelled out with this one. So what you get? 1, 2, 3. 9 to the power 3. Now try to see the pattern. What's the pattern? What's the relationship between 5 and 2 with 3? We can see when we subtract these two powers, you are getting this power. When you get this, what's the symbol here? This is division. Earlier we observed when it's multiplication, you add the powers. Here what we observe, when you divide same base numbers with different powers, you subtract the powers. Now we'll see using that pattern how we can write this one. Same base, different powers, division. Subtract the powers, 4 minus 2. You get 2. This one, 4 minus 7. What is 4 minus 7? Minus 3. Here base is A. 3 minus 8. You get minus 5. This one, x, A and 3, A minus 3. This one, A is the base, x minus minus 3. So minus minus 3 becomes plus 3. This one, A minus B is the power. So then the second law is when you get any base with different powers, division, what we get? Same base, the difference between the powers. So this is the law number 2. So what's law number 2? Law number 2 is same base, different powers, division. We subtract the powers. So here you need to understand, we take different powers here. Same base, division, we subtract the powers. Now we'll use this one. Now here, what is 3 squared? How can we write down 3 squared? I can write 3 times 3. X squared, x into x. Now, something is there. So, whole bracket is there, squared. So, what it means? You get same thing twice. If this is 9 to the power 3, so this is the whole bracket. Now, inside bracket you get 9 to the power 3. So, you get 9 to the power 3 twice. Then, what's using first law? What is multiplication? 9 to the power 3 into 9 to the power 3 is 9 to the power 3 plus 3, 6. Now, look at carefully. You have brackets here. What's the pattern you observe? When you get brackets 3 and 2 with 6, what's the pattern? 3 times 2, you get 6. So, remember this one. When you have brackets, you multiply 3 times 2, you can get the power. So, we'll try to use this in different examples. So, bracket is there. So, what's the pattern we observed? 3 times 2. So, 3 times 2, I'll write 2 times 3, 9 to the power 6. What's the pattern here? 10 squared twice. So, here 10, 2 times 2, 10 to the power 4. What about this one? 2x cubed twice. Can we write this one as 2x to the power 6? Do you think this is correct? No. Why this is not correct? 2 is also twice. 2 to the power 2 we have to consider. So here when you have another number here, think about this is 1. 1 times 2 also you are getting. So here 2 to the power 2. This one now we see the powers. What you do? Multiply both these powers by 2. This one 2 times 2. This one 3 times 2. So what's the answer? A 4 times, B 6 times. This one 2 times x. I can write straight away, that's 2x. This one A and B, x is the base, AB. Now what's the pattern we observed? When you get any base with a power and multiply when it's brackets. So we can write this one is A, M, N. M and N, M times N, M N. So we can highlight this also. This is law number 3. When there's brackets, you multiply the powers. Now we'll try to observe another one. 9 to the power 3, divide by 9 to the power 3. Okay, we'll try to expand this. 9 times 9 times 9, 9 to the power 3. 9 to the power 3 here, 9 times 9 times 9. Now, try to simplify. 9 times 1, 9 times 1. 9 times 1, here, 1 here, 1 here. So, what you get? All these ones, 1 times 1 times 1, you get 1. Now, try to observe this one. We know division of same base, different powers, you subtract the powers. Now, try to subtract 3 minus 3. What's 3 minus 3? 0. So, we see any base to the power 0. You are getting 1. Now, we'll try to use that. Any number to the power 0. What do you think? You are getting 1. Any number. Minus 3 is any number. You are getting 1. 1 is any number. Minus 1, any number. Here xy. Again, power is 0. You are getting 1. This is also power 0. You are getting 1. What about this one? Do you think 0 to the power 0 is 1? This is not 1 and we call this is undefined. Undefined. When you try to use the calculator, you will see you get error term. Error term means we can't find this answer that's not defined in real life. So you can't say 0 to the power 0 is 1. Any number other than 0 to the power 0 is 1. So I can write down what's the other law. Any number to the power 0 is 1, but A cannot be 0. So that's the law number. What's the law now? Law number, we'll see what's the law. Earlier we did law number 3. Now this is law number 4. Now we'll try to use this. Now we'll look at this one. What can you see? You get division. I can write this one as 9 squared is 9 times 9. 9 to the power 5, I can write 9 5 times. 1, 2, 3, 4, 5. Now simplify. This one get cancelled out with this one and you get all ones. So when you simplify, numerator you get 1, denominator 1, 2, 3. 9 to the power 3. When you use second law, same base, different powers, division, you can subtract the powers. I can write this one as 2 minus 5 or 3. Minus 3. 2 minus 5 is minus 3. Now what's the pattern you observe? When you get negative power, you can write as a positive power by taking the reciprocal. Reciprocal means upside down. If this is 1, 1 goes to the numerator, this one goes to the denominator, but powers are different. If it's minus, you are getting plus. Now we'll try to use that pattern in this one. So how can we write down negative power here? 1 over positive power. This one, the base is minus 10. Minus 10 to the power positive 5. This one, base is minus 9. Minus 9 to the power positive 3. This one, I can write A is the base power 4. This one, 1 over x to the power 3. This one, 1 over x to the power b. So what's the pattern you observe? What's the next law? When you get any base with negative power, you can write as the positive power by taking the reciprocal, 1 over am. So that's law number 5. Now take this one, 1 over 9 to the power minus 3. So how can I write this 9 to the power minus 3? I can write as 1 divided by 9 to the power minus 3. Same thing. Now I can write, what is 1? I need to write 1 in any base. 2 to the power 0. 3 to the power 0, 4 to the power 0, all these are 1s. But other one is base 9. I want to write in base 9. Then what is 1? 9 to the power 0. Then what can I do? Law number 2, same base, different powers division, you subtract the power. So here same base, you can subtract 0 minus minus 3. What is 0 minus minus 3? You get positive 3. So what's the pattern we observe now? When this is in negative power in the denominator, you can take that to the positive power by taking the reciprocal. So you can convert negative powers to positive powers or positive powers to negative powers by taking the reciprocal. Now we'll try to use that one. They're asking write in positive indices. So here this is in the denominator. What can we write down? We can write down as positive power. This one, base is minus 11. You can take it up and write down. This is minus 11 to the power 3. This one, x to the power 5. What about this one? 2a is the base now. 2a whole thing to the power 3. Or you can expand and write down this one as 2 to the power 3 and a to the power 3. This one, you can take it up by taking the reciprocal. Minus a becomes plus a. This one becomes minus b is the power, positive power is here. So what's the law from this? Any negative power you can convert to the positive power by taking the reciprocal. Now we'll use all these laws and see, write these in positive indices. So we have to use previous two laws. Any negative power you can convert to positive power by taking the reciprocal. We'll try to do this. Numerator is there. This is negative. I need to convert to positive. So take this one down. Here denominator negative power, take the reciprocal. Take it up. This one goes up as minus 10 to the power 3. This one goes down. Now try this one. 4 goes down as power 2. 9 is the base, goes as power, positive power 8. This one, b goes down as power 3. And here c goes up as positive 7. And what about this one? Negative 8 goes down as positive 8. Minus 5 here goes up as positive 5. This one a and b. Minus a you can write as a. This one you can write as positive b. So we used both the previous laws. Now let's see how we can do the review exercise. For each term in box A, selected the term in box B which is equal to it and join them together. So use all laws we learned. What are the laws? We learned first one is same base, different powers, multiplication, add the powers. Second one we learned same base, different powers, division, we subtract the powers. Third one, when you get brackets, we multiply the powers. Fourth one, any base to the power 0 is 1. Fifth one we did, any negative power we can write as positive power by taking the reciprocal. And sixth one we learned any negative power in the denominator you can write as positive power in the numerator. So those 6 laws we'll try to use here. A into A. This is first law. So what's the answer? A to the power 2. A to the power 2 is there. So here we can join these two. A to the power minus 2 we can write as positive power. Law number 5. And take as this one. So here, this one, here. This one, 1, 2, 3, 4, 5. First law, adding powers, 5 to the power 5. This one. A is there. A is same as A to the power 1. Another way of writing A. This one. You can expand. A times A twice, B and B twice. You get this. 5 to the power 1 is same as 5. 1 over 5 you can write down. This is like this one. You can write as negative power by taking it to the numerator. First one. This one. 5 to the power 1 into 5 to the power 0. 5 to the power 0 is 1. So you will get 5. So same thing you are getting. 5. So here this one. Same answer here. You get twice. X to the power 0 is 1. This one, 5 to the power 3 and 5 to the power 2, you add the powers. 3 plus 2, 5. You are getting same thing. Here, 5 to the power 5. AB to the power minus 1. We can keep A here. B to the power minus 1, you can take it down. A over B. This is what you get here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here, few answers. So, sometimes you get 2 answers there. Here, this one, 2 answers. And this is also 2 answers. Question number 2, fill in the blanks. And you are asked to write down these numbers. 1 over 8. We have to write 8 in base 2. How can we find out 8 in base 2? Take 8 and divide. 2, you get 4. Divide by 2, you get 2. How many 2's you are getting? 3 2's. So, we can put 2 to the power 3. The base is now in the denominator. You have to convert to the numerator. So, what happens? The power becomes negative. You get negative 3. This 100, 100 is 10 times 10. So, 10 to the power 2. When you take it up, that becomes negative 2. 125. How many 5's? How many 5's you are getting? 3 5's. 5 to the power 3. This is the positive power. You can take it up by taking the negative power. This one, 81. How many 3's? You get 4 3's. You can write 3 to the power 4. When you take up, you get negative power. 0.01. Write this decimal in a fraction. This is tens place, hundreds place. 1 over 100. 100 you can write. Earlier we did 10 squared. 10 squared you can write 10 to the power minus 2. This one, tens place, hundreds place and thousands place. 1 over 1000. What is 1000 means? 10 to the power 3. If this is 3, when you take up, that becomes negative 3. Question number 3. Simplify each of the following expressions. We'll use all the laws and try to simplify this. First law, addition is when it's multiplication. We can add 2 plus 3, that's 5. This is also addition, but this is like 1 there. So 5 plus 1, you get 6. This one, 2 laws you have to apply. Numerator, first law, adding the powers. 5 plus 7, you get 12. Now it's division. Division, you get subtraction of powers. 12 minus 11, you get x. X to the power 1, you can write as x. This one, again 2 laws. Addition rule, multiplication becomes addition. 3 plus 5, 8. Denominator also addition rule. 6 plus 2, 8. Now, division rule. Subtract the powers. 8 minus 8, 0. Now, the third rule. Any base to the power 0, you get 1. This one, first law, adding powers. 3 minus 1 becomes 2. And here P1. Use the second law, division becomes subtraction. 2 minus 1 becomes 1. P to the power 1 is P. This one, x to the power 0 is, this becomes 1. 1 times x to the power 5 is x to the power 5 over x. X means x to the power 1. Second rule, division becomes subtraction. 5 minus 1, you get 4. Question number 4. Simplify each of the following expressions and find its value. Use the first law. Multiplication, you can add the powers. Now you are asked to find out the value. 2 5 times. 2 times 2 times 2 times 2 times 2. You get 32. This one, division. Division becomes subtraction of powers. 7 minus 4, you get 3. 3 to the power 3. 3 times 3, 9. 9 times 3, 27. Here, first add the powers. 8 plus 2, you get 10. And then subtract the powers. 3, 10 minus 5 becomes 5. What is 3 to the power 5? Can you remember? 243. 3 times 3, 9. 9 times 3, 27. 27 times 3, 81. 81 times 3, 243. This one, adding powers. 5 to the power 3 plus 0 is 3. And here 5 to the power 1. Then 3 and 1, this is division. 3 minus 1, you get 5 to the power 2. What is 5 to the power 2? 5 times 5, 25. This one, 10 base. Adding powers, 3 plus 2, you get 5. Here adding powers, this is like 1. 4 plus 1, 5. Same base. Different division becomes subtraction. 5 minus 5, 0. 10 to the power 0 is always 1. This one, 2 to the power. Adding powers 5 and 3 becomes 8. Here 6 plus 2, again 8. Subtract the powers when it's division. 8 minus 8 becomes 0. 2 to the power 0 is 1. Now we'll look at logarithms. So we covered all the laws of indices. So we'll take what are logarithms. Now we'll take the power of 2. We know 2 to the power 0 is 1. 2 to the power 1 is 1. 2 to the power 2, 4. So you are multiplying by 2. So 2 to the power 10 is 1024. Now we'll try to write down all these numbers in base 2. We can use this table. 64 I can take as 2 to the power 6. 512 is 2 to the power 9. And 128 2 to the power 7. Now when you use laws of indices, 9 plus 6, 15, and here 2 to the power 7. Subtract the powers, 15 minus 7, 2 to the power 8. So when you take 2 to the power 8, what's the value? You get 256. This one, 128, 2 to the power 7. 64, 2 to the power 6. 32, 2 to the power 5, and 16 is 2 to the power 4. Now use laws of indices. 7 plus 6, 13. 5 plus 9, 5 plus 4, 9. 13 minus 9, you get 2 to the power 4. 2 to the power 4 is 16. Now we'll take these index notations. So here finally we got 2 to the power 8 is 256 and 2 to the power 4 is 16. Now we'll try to write this index notation in logarithmic form. We found out from the previous one 2 to the power 4 is 16. Now we'll try to write this in another form, logarithm form. When you are writing logarithm form, we need to know these three. This is the base and this is the index and this is just the number. So when we are writing in logarithmic form, log form, what happens? We take the notation log to represent it's a logarithmic value, and base goes here and the number comes here. The logarithm of 16 becomes the index. So what's the logarithm means? The index of the number. So we can write down 2 to the power 4 is equal to 16. Then same thing I can write in log form. So this base comes here, index is here, and 16 is just the number we got. Now earlier what's the other one we got? We got 2 to the power 8 is 256. Now we'll try to write down that also in log form. So how can we write down? Log to represent that's a logarithmic value. Base goes here and the number comes there. This becomes the index. So look at the pattern. So when you write this one, it's easy to convert back to this form. How? We can do this way here as well as this way. Yeah. Both ways you can apply. Here, look at carefully these two. 2 to the power 4 is 60. So both ways learn how to write down index form as well as logarithmic form. Now we'll see this one. Write these in logarithmic form. Now we know how to convert any index form to log form. How we do? Log. This is the base. Base goes here. Number is 64. Becomes the index. Now try this one. You can write as log. What's the base now? Base is 3. The number is 81. That becomes the index. Base is 10 here. The number is 1000 is equal to the index. Here base is A. The number is X is equal to the index M. And this one LOG, base is A, the number is Y and the index is N. Now we know how to write down index notation to log notation as well as log notation to index notation. Write these in index form, other way around. So what's the pattern? This way. I told you, consider this way. 3 to the power 2 is equal to 9. Then here, think about base and the index. 5 to the power 3 is equal to 125. This one. 6 to the power 3 is 216. Now try these in index notation. 3 to the power 6 is equal to 729. This one, a to the power m is equal to x. Last one, a to the power n is equal to y. Write these in log form. So this is index form given. So same as before, we can take log notation. What's the base here? Base is a. So we can write a here and the number is this one, x into y, becomes the index. Index is m plus n. Now try this one. Any expression is there. So try with this one. This is the number. What is the base? Base is a and the number becomes x divided by y here. That's equal to the index. What is index here? M minus n. Practice this, how to write. Now, practice this, how to write down index notation to log notation as well as other way around. Now we'll take what is 2? 2 to the power 1. What's 3? 3 to the power 1. 10? 10 to the power 1. How can you write a? A to the power 1. Now we'll try to convert this to log notation. All these try to convert to log notation. Log, base is here, base 2 and the number 2 is 1. This one, what's the base? Base is 3, the number is also 3, equal to the index 1. Here 10 base is there, the number is 10 equals to 1, and here a base is there, the number a is equal to 1. What's the pattern you observe? When you take log notation, same base, same number, you always get 1. So remember this logarithmic law now. Same base with same number, you get always 1. This is a logarithmic law. I'll write in blue, law number 1 in logarithmic notation. We'll take this one. 1 is 2 to the power 0. 3 to the power 0 is also 1. 10 to the power 0 is always 1. And we can take any base to the power 0 is 1. Now, try to convert to log notation. What happens? Log base 2, 1 equals 0. Here, log base 3, 1, 0. This here the base is 10. 1 is the number. Here the base is A, 1 is the number. What's the pattern you observe here? Different bases, but the number is 1. Different bases, number is 1 is always 0 in logarithms. So the second law in logarithms, any base 1 is 0. So remember this also, this is another law in logarithms. Now we'll take this one. 8 is 2 to the power 3. 32 is 2 to the power 5. Write this in log notation. Log 2 base 8 equals 3. Write this also in log notation. Log 2 base 32 is 5. This is also a number. Try to write down this one in log notation. Log. So before that we need to identify a pattern first. So we'll take this one, these two. Here, how we get 8? 8 is 2 to the power 3. How you get 32? 32 is 2 to the power 5. Now we can use the law. Now here what you get? 2 to the power. Use index laws. 3 plus 5. You get, here I can write adding powers when you get multiplication in indices. This one I can consider as log notation. Try to write third equation in log notation. Log base is 2 now. The number is 8 times 32. That's equal to the index 3 plus 5. Using 1 and 2, I can write 3 as log 2 8 and 5 as log 2 32. So what's the pattern I get? Log 2 8 times 32 is equal to log 2 8 plus log 2 32. Look at carefully. What's the pattern? When you get multiplication inside logarithms, you can take separate logarithms with addition. Now we'll see this pattern and write down a general form. We'll take x as a to the power m. How can I write this in log notation? Log base a x equals m. This one I can take as log a base y equals n. So, if this is multiplication, what can I write? X times y. If I want to multiply these two, this becomes a to the power m times a to the power n, a to the power m plus n. Then when I want to write down this one in log notation, I can write log a base x into y equals m plus n. Now using m plus n, what can I write using equation 1 and 2? This is 1, this is 2 and this is 3. Using the third equation and plug the values in 1 and 2, you get m as log ax, n as log ay. So this is the next law. Law number, which law? We did law number 2. This is law number 3. So law number 3 says multiplication of logarithms you can write as addition of logarithms. And this is another important thing in logarithms, LG. So in certain books we see LG notation. LG is same as log 10 base. So you can't write log 2 base is LG. Only when the base is 10 we can use as LG. So remember that notation throughout we are using LG. So LG means log 10 base. Now we'll look at expand using these ones. Expand using laws of logarithms. So what's the law we found out before? Multiplication of logs becomes addition separately. So I can write log 2.32 plus LG 1.78. This one also multiplication. Multiplication I can write addition of logarithms 27.9 plus LG 37.4. This one 3 terms, but still this is multiplication. I can write as LG 2.63 plus LG 21.4 plus LG 38.5. Write these in single log notation. Now the other way around. Log addition is given. How can we write in single notation, logarithmic notation? Inside this becomes multiplication. I can write down these two multiplied by each other in LG notation. This is also addition. Addition becomes multiplication. I can write 81.7 multiplied by 4.15. This one, same thing. Multiplication becomes addition. So this addition separately becomes inside multiplication. Now we'll take this one. Now we found a pattern for multiplication. Now we are trying to find a pattern for division. 729 is 3 to the power 6. Write this in log notation. Log 3 base 729 is 6. I'll take this one as 1. This one, 81 is 3 to the power 4. Log 3 base 81 is equal to 4. Now I want division. So 729, I can write 3 to the power 6, 81, 3 to the power 4. When you use division with index laws, this becomes subtraction. 6 minus 4 is 2. Or I can write without writing 2, 6 minus 4. Then now I can write down this one in log notation. So this is the number. Log 3 base. The number 729 divided by 81 is 6 minus 4. I'll take this one as third equation. I'll take the third equation and plug the first and second equations in the right hand side. So what am I getting? Log 3 base 129 over 81 is equal to 6 minus 4. 6 is log 3 base 729 minus 4 means log 3 base 81. Now what we see? Addition becomes subtraction of logarithm. So we'll try to find out a general form. X is a to the power m. So what is this one in log notation? A base x is m. I'll take this one as first equation. Y equals a to the power n. Write in log notation a base y equals n. Now division x and y. X becomes a to the power m and y is a to the power n. When you use laws of indices, this becomes subtraction. Now we'll write this one in log notation. Log a base, what's the number now? X over y is equal to a. Here it becomes the index m minus n. I'll take this one as third equation and plug first and second equations there. So when you take third equation, I'm getting log a base x over y is equal to m. What is m from first equation? Log a base x. What's n? This is subtraction. N is log a base y. So this is the next law. Law number 4. When you get division in logarithm, you can write as subtraction of logarithms. Now using that law, expand these ones. So here multiplication as well as division is there. So we'll try to use both laws. Division only here. So what we can write? LG 73.5 minus LG 7.17. Again this one logarithmic laws for division. 618.3 minus LG 9.5. This one multiplication as well as division. I can write these two as addition. 7.83 plus LG 5.14 because this is multiplication. Now the division. Division is subtraction. LG 4.93. This one, first one we have to write LG 814.3. And then this whole thing is in the denominator. So either you can write this is minus and put a bracket and write down this is plus. LG 7.55 plus LG 4.12, or I can write straight away opening brackets because this is in the numerator. I can write LG 814.3 minus LG 7.55 minus LG 4.12. So I'll try to write down the second one at once. So this one, without writing the first step, we'll try to write down both with negative signs. Now do that. These two in the numerator. So straight away LG 31.4 plus LG 48.3. Then these two in denominator, I can straight away write down both numbers as negative values. LG 9.33. So these two pluses because those are in the numerator. Other two in the denominator, both are negatives. Write these in single log notation. Now we'll do reverse process. Subtraction is there. What is subtraction? We can write as division. So 83.5 divide by 7.94. Here I have seen some students are writing LG 83.5 divide by LG 7.94. That's wrong. We just write one LG. This one, first two, addition. You can write as multiplication. 9.17 times 8.17. But this one is with minus. Minus becomes division. Now try to write down this one at once. What are the multiplication values? Addition values becomes multiplication. So I can write 49.3 multiplied by 70.3 because both are pluses. This is negative, means that goes to the denominator as division. Try to write down this one in one single LG notation. This one is plus and this is plus. So these two in the numerator. 84.3 multiplied by 61.77. These two minuses, it goes to the denominator. 35.73 and 21. This multiplication. Because both minus, when you take minus out, that becomes plus. Plus means multiplication. 35.73 and 21.4. We'll take example number 1. Find the value represented by x in each of the following. Now, this is in log notation. I can write this as index notation. What's the rule? I can write 2 to the power x is equal to 64. What is 64? 2 to the power 6. If you can't remember, you can divide and see. 2 times 32, 64 again, 16, divide by 2, divide by 2 again and 2 again. So how many 2's are there? 6 2's. Then you can write down same base, both are equal, then you can equate the powers. So x equals to 6. This one again, write in index notation or index form. X to the power 4 is equal to 81. 81 is how many 3's? 3's. When you divide by 3, you get 3 4's. 3, 3, 3, 4 times. I can write this as 3 to the power 4. Can we write like this? You get only half of a mark, because when you get an even power, you can consider negative numbers as well, because negative 3, negative 3, negative 3, negative 3 also becomes positive 81. So when you get any even power, think about positive as well as negative powers. Now, same powers, you can equate the numbers. So, x is positive or negative 3. But this is in log notation. We can't get negative bases. So, remember that not define logarithms for negative bases. So, therefore, only we can take positive 3. Write down that important thing, not define. Logarithms for negative bases. Third one, write in index notation, 5 squared is x. So what is 5 squared? 5 times 5. So x becomes 25. So we did 3 different types of questions. Here the number is unknown, base is unknown, and this one inside. This is the number. Number is unknown. Here the index is unknown. All 3 types we discussed. Now we'll take a similar question. These are my examples. Now, index is unknown. How we do? How we do this? Again, write in index notation. 5 to the power x is equal to 125. Then 125 is 5 to the power 3. Then what can I write about the powers? Same bases are equal, so x becomes 3. Now the base is unknown. What can I write down? In index notation I can write down x to the power 5 is 32. The power is now odd. Odd numbers we can't write both positive or negative. So what's the power for 32? We can divide by 2's and write down this one as 2 to the power 5. Same powers, you can equate the bases. So x equals 2. This one, write in index notation, 4 squared is equal to x. 4 squared is 16. So here we can find out the unknown values using index forms and logarithmic forms. Exercise 19.1. Write each of the following expressions in logarithmic form. The logarithm of 32 to base 2 is 5. The logarithm of 32. I can write log 32 base 2. Base is here is 5 equals to 5. Now write down the second one in log notation. The logarithm of 1000 to the base 10 is equal to 3. Third one, I'll do it here. Logarithm of x to the base 2 is y. Fourth one, logarithm of q to the base p is r. Last one, the logarithm of r to the base q is equal to p. So this is how we write down logarithmic form. Question number 2. Express each of the following in index form. So what's the method? I can write this way. 5 to the power 3 is equal to 125. This one, I can consider this one. 10 to the power 5 is equal to 100,000. This one, a to the power y is equal to x. Here, p to the power q is equal to a. Fifth one, take this one here. A to the power 0 is equal to 1. This one, m to the power 1 equals m. Question number 3. Express each of the following in logarithm form. Now other way around. How you write in log notation? Log base, you write here, the number 256 is equal to the index. Log base 10 of this number is equal to the index. This one, log base to this number equals the index. Log base is 20. The number 400 is equal to the index 2. Again, this one, log base a to this number y is equal to the index x. Log base p to the number q is equal to the index a. Question number 4. Solve each of the following equations. Now we'll try to write in index notation and solve. Write this one in index notation. 3 to the power x is equal to 243. Now write down what is 243 in base 3. So you get 81 divided by 3 again, 27, 9 and 3 again. So 3 to the power 5. Same base, different powers. You can equate the power. So x becomes 5. This one you can write in index notation. 10 to the power x is 100. What is 100? 100 we know, 10 squared. Same base, you can equate the powers. So x equals 2. This one, 6 to the power x is 216. So you can find out how many 6s. 216 divided by 6, 36, again 6, 6. So 3 6s. So I can write 6 to the power 3 is 6 to the power x. same base you can equate the powers. X equals 3. This one, write in index notation. X squared is equal to 25. What is 25? As a square term, I can write plus or minus 5 because this is an even power. And then same power you can equate the bases. But we know this is the base. Base cannot be negative. Therefore, we can write x equals plus 5. This one, write in index notation. X to the power 6 is 64. Again, even power. You can consider plus or minus. What is 64? We know that when you divide by 2, you get 2 to the power 6. Divide and see. This is 2 to the power 6. But this is even power. You can consider plus or minus 2. So, powers are equal. You can write plus or minus 2. But x is the base. Only take the positive value. Here, x to the power 1 equals 10. So, straight away, I get x equals 10. This one, 3 squared. 3 squared is equal to x. So, x becomes 3 times 3, 9. This one, 10 to the power 4 is x. So, 10 to the power 4 is 1, 2, 3, 4 zeros. That's 10,000. This one, 8 squared is equal to x. 8 times 8, 64. Question number 5. Write 64 as a power of 4 different bases. So, we'll try to write down with 4 different bases. 64, I can divide by 2. I can get 2 to the power 6. So, I can write 64 in base 2 and write 2 to the power 6. If I take base 4, 4, 4, 4. How many 4s are there? 4 to the power 3. Again, if I take 8, how many 8s are there? Then I can take here 8 and another 8. 8 times 8. 8 to the power 2. And if I take 64 as the base, I can write 64 to the power 1. So, these are the 4 different ways I can write 64. Find 4 distinct pairs of values for x and y such that log x base 64 is equal to y. That means I can write down all these in log notation and find out what's x and y. In this case, log base 2 64 is equal to 6. So, what's the x value? X equals 2 and y equals 6. Now, we'll take this one, log 4 base now. 4 base 64 equals 3. X here is 4 and y is 3. This one, log 8 base 64 is equal to 2. What's the x value now? X is 8 y equals 2. Here write in log notation, log 64 base 64 equals 1. Therefore, x equals 64 and y equals 1. So, those are the 4 distinct pairs of values for x and y. Example 1. Find the value of each of the expressions given below. So, we can use laws of logarithms now. What's the first law? Not the first one. We did this law when it's addition, you can write as multiplication of logs. So, same base, I can write 32 times 2 and write down what is 32 times 2? This is 64. Now we can simplify further. 64 is 4 to the power 3. 64 I can write as 4 to the power 3. We know logarithm of a number is the index. So what's the answer? Logarithm of the number is the index. So I can write as 3. This one, subtraction now. We can divide the two numbers. 15 divided by 3. 15 divided by 3 is log 5 base 5. Same base, same number. According to the law, you can write as 1. Example number 2. Evaluate this. Here addition as well as subtraction. How can I write down this one? Same base. Multiplication I can write as addition, I can write as multiplication. Subtraction I can write as division. Then simplify 2 times 4. 4 times 25 is 100. Log 10 base 100. We know 100 is 10 squared. Logarithm of a number is the index. So what's the index here? You get 2. Example number 3. Express in terms of log a2 and log a base 3. 6 is there. So we need to think about how can we write down 6 in terms of 2 and 3. So that's 2 times 3. Then apply the laws. Multiplication becomes addition. I can write as log a base 2 plus a base 3. Then this is a base 2 and this is a base 3. Now 18, how can I write in base 2 and 3? I can write 18 as prime factors 2 and 3. Divide by 2, you get 9. Divide by 3, 3 and 3. So I can write down 18 as 2 times 3 times 3. Now use addition law. Addition is the multiplication inside the logarithm. I can write log a2 plus log a3 plus log a3. These two are the same. I can add and write as 2 log a base 3. Example number 4, solve. So we'll take the left hand side. Addition is there. Addition becomes multiplication. I can write as 5x. Now take the right hand side. You get addition as well as subtraction. I can write a base. These two multiplication and this one division. And simplify 2 times 1, 2 times 5. So what you get? Log a base 5x equals log a base 15. Now here, this is an equation. Log a base is there. So you can compare the inside numbers. So I can write 5x is equal to 15. So what is x? 15 divided by 5. I get 3 as the answer. Exercise 19.2. Simplify and express the answer as a single logarithm. Addition. Addition becomes multiplication of numbers. 10 times 5 is 50. Log 2 base 50. This one, addition, I can write multiplication. Addition as multiplication of logs. 8 times 5, 40. This is addition of logarithms. Use the law. Multiply inside 3. 7 times 3 times 5. So you get 7 times 5, 35. 35 times 3, 105. This one, subtraction. Subtraction becomes division. 4 times 5. So log 6 base 5. Fifth one. Now try, this is plus, means that should be in the numerator, and minus becomes division. 2 and 5 in the denominator. 5 times 2, 10. 10 divided by 10, you get 1. So a base 1. What is this one? According to the law, any base 1 is 0. This one, log 10 base. These two multiplication. And this one, division. 3 times 2, 6. 2 times 2, 4. Find the value of each of the following expressions. Now you are asked to find the value. First, use the laws of logarithms. Addition becomes multiplication. You get 232. 2 base 32. We know 32 is 2 to the power 5. Logarithm of a number is same as the index. So what's the index here? Index is 5. Log 3 base division, because it's subtraction there. 27 divided by 3. You get 9. 9 is 3 squared. Logarithm of a number is the index. So the answer is 2. Here same base 10. These two multiplication, and this one is negative means subtraction. This one is negative means dividing by 4. 5 times 2, 10. Same base, same number. What's the answer according to logarithmic law? That should be 1. This one, same base. These two addition means you multiply. This one is subtraction, that means divide. 5 times 3, 5 times 1, 5, 6. Then 3 times 4. So 16 times 4. Log 2 base. 16 times 4, 4 times 6, 24. 4 times 1, so 64. What is 64? We know that 64 is 2 to the power 6. So logarithm of the number is the index. So the answer is 6. This one, same base, multiplication these two. numbers and divide by this. 10 times 10, 100. 100 is 10 squared. Logarithm of a number is the index. So, index is 2. This one, 5 base. These two multiplication and this one is division. 4 times 4, 4 times 5. Same base, same number. What's the answer? You get 1 according to the law. Write the following expressions in terms of log A5 and log A3. So 15 you have to write in terms of 5 and 3. What's 15? 5 and 3. Multiplication inside becomes, you can write separate addition of logarithms. This one, division. Division becomes subtraction of numbers. Here there's a mistake. This should be base A. This one, third one, this should be 25 because otherwise the same question. So this is division. You can write as 3A base 25 minus A base 3. 25 I can again write as 5 times 5. This one, 5 times 5, multiplication, write in addition. 5 plus log A5 minus log A3. These two are the same. I can write as log, this is twice of that, 2 log A base 5 minus log A base 3. Fourth part, 45. How can I write 45 in terms of 3 and 5? 3 times 5. So I can write 3 times 5, use addition 1 for multiplication, separate addition of logarithms for multiplication inside, log A base 3 plus log A base 3 plus log A base 5. These two are the same. I can write 2 log A base 3 and log A base 5. 75, how can I write in terms of 3 and 5? 3 times 5 times 5. So 3 times 5 times 5. Then use addition of logarithms. 3 plus log A5 plus log A5. Now these two are the same. I can write log A base 3 plus 2 log A base 5. This one 225. How can I write 225? When I divide by 3, I get 75. Then again divide by 3, I get 25. Then 5 and 5. So instead of 225, I can write 3 times 3 times 5 times 5. Now use adding these logarithm values. Log A base 3 plus log A base 3 plus log A base 5 plus log A base 5. These two are the same and these two are the same. Now you can write 2 log A base 3 plus 2 log a base 5. Question number 4. Solve the following equations. So we'll try to do the left side. Left side, same base. Addition becomes multiplication. Now what you get? 15 is equal to log 2 base x. Same log notation, you can compare the inside value. So x equals 15. This one, take the left hand side and use the law. Log a base 10 and x you can write as multiplication. 10x is equal to log a base 30. So same base, you can compare the numbers. So 10x equals 30, x becomes 30 divided by 10, that's 3. Third one, left hand side, same base, you can multiply the values too. So 20x. Here also same base, multiply the values, you can write. So 4 times 10, you get 40. Now same base with logarithms, you can compare the inside part. So 20x equals 40. So what is x? 40 divided by 20, you get the value as 2. This one, take the left hand side. Subtraction is there. Subtraction becomes division. Division of numbers. So then what happens here? 15 divided by 3 is 5. Same base logarithm. You can compare the inside values. X equals 5. Here, we'll take the left hand side. Use laws of logarithms. Same base. These two multiplication and this one division. 2 and 8, you get 4x. Same base, logarithms, you can compare the inside values. 4x equals 12, x becomes 12 divided by 4, that's 3. This one, look at the left hand side, laws of logarithms. Same base, subtraction becomes division. Right hand side, same base, addition becomes multiplication. Now compare the two sides. Same base logarithms, you can compare inside. This is 24 over 4 is 6. So 6 equals 2x. X becomes 6 divided by 2. That's equal to 3. So x equals 3. Miscellaneous exercise. Evaluate the following. So you can use laws of logarithms. Here, can you use laws of logarithms here? Different bases. So here we can't use addition law. We can do separately. 27 I can write 3 to the power 3. Logarithm of a number is the index. So this is 3. 8 is 2 to the power 3. Logarithm of a number is the index. So this becomes 2 to the power 3. 3 plus 3, you get 6. This one, same base. So you can use the laws of logarithm. 243 divided by 27. So 27 to 3 to the power 5 and 3 to the power 3. So here 9 times 27 is 243. So 9 times 27. Then log 3 base 9. We know 3 squared is 9. Logarithm of a number is the index. So what's the answer? Answer is 2. This one, not the same base. Separately we'll do. 16 is 2 to the power 4. So what's this one? Logarithm of a number is the index 4 multiplied by. Again 9 is 3 squared. Logarithm of a number is the index, that's 2. 4 times 2, you get 8. This one, you can apply the law for the first part. Here, 10, same base, same number is 1. 32, how can we write down 32 in terms of 2? 2 to the power 5. So 2 to the power 5 is 34. So you can write logarithm of a number is the index, that's 5. This one, same base. Addition becomes multiplication and subtraction becomes division. 15 divided by 15, you get log a base 1. Any base 1 is 0. Question number 2. If log 2 base 24 is x, express log 2 base 48 in terms of x. We need to find out log 2 base 48. So what is 48 in terms of 24? 48 is 24 times 2. I can write this one as 24 times 2. Then use laws of logarithms. Multiplication is addition of separate logarithms. But I know log 2 base 24 is x. What is log 2 base 2? Same base, same number is 1. So the answer is x plus 1. Question number 3, verify each of the following expressions. So verification means you take the left hand side separately and right hand side separately and show that both sides are equal. We'll take right hand side. Use laws of logarithms. Same base, subtraction of logarithms, that means division. So I can write 5 over 18. Left hand side, this is addition. Addition becomes, I can write as multiplication. This one multiplied by 25 over 81. Then try to simplify this. 9 times 1, 9 times 9. 5 times 2, 5 times 5. So what's the answer there? Log a base 5 over 9 times 2, 80. Now can we see this one and this one? Both sides are the same. So right hand side is equal to left hand side. So that means it's verified. Question number 2, part 2. You have to verify this. So we'll take the left hand side and simplify. And if we can show that that's 1, that means we can easily verify that. Same base, you can use laws of logarithms. These 3 addition. Addition means multiply. This one subtraction means division. 2 times 4, 4 times 5. Log 5 base 5. Same base, same number, you get 1. So this is same as right hand side. So that's, therefore, it's verified. Part 3, we'll take the left hand side. These two, we can use the addition law. 10 base 2 times 3. Addition means multiplication. Minus 1. Then I can write 2 times 3 as 6 minus 1. That's left hand side. Right hand side, what can I write? Right hand side I can take as 0.6. 0.6 I can write 6 over 10 in fractions. 6 over 10. So 6 over 10, this division I can write separately as subtraction. 10 log 10 base 6 minus log 10 base 10. So what is log 10 base 10? That's 1. Log 10 base 6 minus 1. So this is the second equation. Here see left hand side and right hand side both are equal. So I can write right hand side is equal to left hand side. So that, therefore it's verified. Question number 4. Evaluate. Evaluate means find the answer. We'll use the laws of logarithm. LOG 10 base. These two multiply each other and this one becomes division. Now simplify. 1 0 get cancelled out. 6 times 5. 5 times 2, 10. So you get 1000. Log 10 base 1000. We know 1000 is 10 to the power 3. So logarithm of a number is the index. So the answer is 3. Part 2. Now try to use the laws of logarithm. Same base. So here we multiply these two and divide by 2 over 7. Now I can write this one as multiplication and take the reciprocal of that. Now simplify. 7 times 1, 7 times 3, 5 times 5, 2 times 6, 6 times here 3 times 2, log 10 base 10. Same base, same number, you get 1. Question number 5, you are asked to solve, find the x value. So we'll take the left side of the equation, apply the law, 10 base x over 2, because this is subtraction. This side, log 10 base 3 over 4. And I can write 1 as log 10 base 10. The same base, same number is 1. Now again, this is addition. I can write as multiplication. 3 times 10 divided by 4. Now both sides you get log 10 base. So you can compare the inside part. So x over 2 becomes 3 times 10 over 4 divided by 2. You can find x as this 2 also get cancelled out. So when you cross multiply 3 times 2 times 5 divided by 2, you get x as 50. This one, we'll take the left hand side, log 2 base. This becomes division. 12 divided by 3, log 2 base x plus 1. 3 times 4. So log 2 base 4 is equal to log 2x plus 1. 1 I can write as log 2 base 2. Why I am writing in base 2? Because all the other log values are in base 2. Now again apply the laws of logarithm. Addition becomes multiplication. Same log base, you can compare the inside values. So 4 equals 2x. So what is x? 4 divided by 2, that's equal to 2. In this lesson, we covered all laws of logarithms and indices, and next chapter, Logarithm 2, is about referring log tables.